So knowing the subject is of course very important. It is beyond preparation. It's not just about preparing a few facts, but actually knowing your subject. So here are 10 different types of observations that contribute to the scientific evidence that global climate is warming. White upward arrows indicate increasing quantities and black downward arrows indicate decreasing quantities. So we can measure obviously carbon dioxide and so on. We'll look at the details as we go along. But the consequence, we're increasing greenhouse gases. We will see why we can confidently say we are increasing it. Obviously, air temperature is increasing near the surface in the troposphere, the lower part of the atmosphere where we live and where all the weather happens. Warmer air holds more moisture, so water vapor is increasing. Together, they increase the warming. They further enhance the warming, what we call positive feedback, but apparently this can be misconstrued by some lay people, because positive feedback can be somebody telling you you did a good job, whereas in our climate science, positive feedback is something that can amplify an initial perturbation. So enhance may be a better word. Okay, so they enhance the warming because water vapor is a strong greenhouse gas. It traps outgoing long wave energy, and that leads to melting of glaciers and ice sheets, and also snow cover. The temperature over land also increasing, temperature over the oceans, sea ice decreasing, sea level increasing, ocean heat content increasing. So few things decreasing are glaciers and ice sheets and sea ice, snow cover, and so on. Okay. But what is the context? So now you know your basic facts, that it's warming, that it's caused by us. It hasn't stopped. Global warming hasn't stopped. The heat is mainly in the ocean, we'll see later. Sea level is rising, global mean, but as I said, not everywhere, so you have to be careful. Ice is shrinking almost everywhere, but not everywhere, because it depends on the complications, like over Antarctica. CO2 makes ocean more acidic, no doubt at all. CO2 dissolves easily into water, and that decreases the pH or makes it more acidic, which can dissolve corals or make them make it harder for them to grow. Other shell-forming animals, plankton. CO2 in the air is up 45% since the 1800s, and every year it increases by a couple of percentage, which is really more rapid than anything we have seen in many million years. Okay, it's now the highest in millions of years. Cumulative emissions set the warming, which means CO2 is a inert gas which has a long residence time in the atmosphere, so it can stick around for centuries or even millennia, and that means it's accumulating, and this accumulation becomes critical for the warming as well. Reducing emissions limits the warming. Reducing emissions limits the warming, no doubt at all. Climate change will last for centuries. That doesn't mean we cannot start acting right now. It is very important, in fact, to start acting right now. There's an old story that a house owner told the gardener to plant a few trees in his garden, and the gardener said, "But sir, that'll take decades to get grow up." The owner said, "Well, then we must start immediately, right? Planting trees immediately, because it'll take decades to grow." That's what climate change is like. It is happening, and it will be it is accelerating as well, but we must start immediately. So the second step of communicating effectively is to have stories. So the example Richard uses is called Uncle Pete, who's got so much misinformation in his head that he has collected from friends, from the social media, from skeptical media, from reading skeptical outlets, and so on. And he always shows up for family dinners and keeps arguing. And as I said before, these are people who are convinced that they already know climate change. They wouldn't probably do the same about medical field or astrophysics, but somehow with climate everybody feels comfortable, right? Weather, everybody knows weather. As a climate scientist, I never meet people who want to ask about climate change. They want to tell me about climate change, what they already know. So for the Indian context, we'll make him Pandu Kaka. Pandu Kaka already knows something, and he's going to keep arguing. So there are good resources like skepticalscience.com and realclimate.org that provide incredibly up-to-date information, and they answer all the questions that are typically thrown at climate change science by media with vested interest, media that want to deny climate change for whatever reason. Okay, so these people take those questions, answer why they are wrong, and provide related data, model output, words, information, knowledge, understanding, everything you would need. Okay, so this is very critical to be able to know all the basic facts about climate change. And of course, the deep understanding means you will have to know the physics behind it. But as I sit here and I have recorded social science and religion and communication, I'm not an expert in those, but I read the chapters, I did a lot of research, I added my own research to the chapters before recording them. But I also gave a caveat that I'm not an expert in those fields and that I would like to re-record them when I get collaborators to record those parts. So you have to be aware of your strengths and weaknesses, and you have to be very honest about answering them by saying, this is not my field, but here is what I know. And then you should be able to get more information for people who ask you questions in the related climate change fields. Okay, I do a lot of reading and research on human behavior, risk perception, and so on, because I'm very curious as to why climate change is such a controversial topic. But my main research is still climate change science, so I always have to be very careful when venturing into those other fields. But I should also make sure I know enough to talk about and be sure of what I'm saying. So those are kind of things we all have to watch out for.